we're going to do overlapping triangles today. So sometimes we have triangles that will have an angle or a side that they share. And we've already talked about this a little bit with like the reflexive property. We've had a lot of shared sides. But they haven't necessarily been like overlapping each other. I think I snuck one into your practice last week. You might have caught it, but now we're going to have like a whole lot of overlapping triangles. So our first example asks us to separate and redraw triangle DFG. That's this one. And triangle EHG. So this is how we separate them. We just do our best because maybe none of us are artists. Okay, so this is my first triangle. So this is DFG. And then I have to draw the other one as best I can. Okay, it's not going to be perfect, but you get the idea. This would be EHG. And it says to identify the common angle, and you can see that they are sharing this angle G. And that's how we can identify it with those congruent arcs. That's all we have to do. So we're just going to be using that in our proofs today. All right, look at this next example. We have to name the common side for triangle ADC. ADC and triangle BCD. 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 So you can see that the common side is the one that I highlighted twice that turned not just pink or blue, but purple. It's this one right here. Okay, so that is, I'll do it in purple. And notice the order of the letters. In triangle ADC, it is side DC. And with a little bar. And in triangle BCD, it is side CD. That is the side that they share. Okay, so we have to find another pair of triangles that share a common side. Well, there are lots. I'm not going to do the top part of the triangle because I don't want to muck that up, but I'm going to add some more letters. I'm going to call this point F, and call this point G, and this will be H down here. I could say this triangle, and let's say, oh, my brain, this one. I mean, there's so many that we could have picked. Those are just two that are jumping out at me, and they don't share exactly the same kind of side as the other two, so I like this pair. All right, so the first one I picked was FEG. So that would be triangle FEG. And I want to say that it is congruent to, now make sure you get it in the right order. So F for the orange is going to correspond to E for the red, triangle E, and then F, and then H. E, F, H. All right, and then we have to name their common side. So that side is the FE side. FE, and look at the order again. The order is flip-flopped. Okay, so it'll be side FE is congruent to side EF. Okay, make sure you get the order right. All right, here we go. Next one. Easy so far. Okay, we get to separate and redraw again. We want triangle A, D, C. A, D. Ooh, I thought it was on my highlighter and it was not. A, D, C. And triangle A, D, E. Okay, so we'll separate and redraw those. Oh, that was terrible. I can do better. I can do better. This is really hard to do from far away from the board. Or, I mean, I'm too close to the board is what I'm trying to say. Okay, A, it's excuses. It's excuses. Okay, that's one of them. Okay, here's the other one. Oh, good grief. Okay, I think I did better on that one. A, practice makes perfect. A, D, E. All right, now we have to code and label them. So, they already have some arc marks. This angle A is congruent to that angle A. This angle C, boop, boop, is congruent to that angle E, boop, boop. Okay, and then the last thing we know is this, that this was congruent to itself, right? So I'm going to mark that. AD is congruent to AD. Now we have to write a triangle congruent statement. So matching up the corresponding parts, I'm going to say that triangle ADC is congruent to triangle ADE. Okay. Which theorem can be used to prove the triangles are congruent? Okay, well, this is fun. I can't go angle, side, angle. Let's talk about why. So the first thing is that I have an unknown side and then an unknown angle. Remember, whenever I have two pieces of unknown information in a row, I can't go that direction. It's like a roadblock, okay? So I have to go the other way. So I have an angle and then an unknown, but then I have another angle and then I have a side. So I'm allowed to go this way because I'm only jumping over one unknown. I can't go the other way. It's roadblocked because I have two unknowns. Can't go. No way. So this is angle, angle, side. Let's double check that this picture matches. So I have angle, angle, side again. Angle, angle, side. Okay, was that the end of that page? We might be going really fast, guys. I don't know. I don't know. Okay, so we are going to use the trick of redrawing our triangles separate. So the first one I want to draw is ACB. ACB. That's this guy. Oh my gosh, that's terrible. It's fine, it's fine. A, C, D. The show must go on. The show must go on. All right, then we want E, C, B. Gotta go home and eat. Okay. Oh, that's terrible. It's fine. Okay. I don't know who I'm trying to convince, me or you. Okay, so you can see that they share angle C. Boop, boop. Okay, let's see if they give us any other fun information we can use. Okay, we see that CD is congruent to CB. Boop, boop. And that angle CDA is congruent to angle CBE. CBE. Okay, that makes sense. So it looks like we have angle side angle. Just saying, doesn't it? All right, so let's start with our givens. Given CD, the segment, is congruent to segment CB. That is given. Okay, next, I know that angle CDA is congruent to angle CBE. That was also given to me. Thank you very much. Now, that takes care of my two given pieces of information. Now I have that angle C that I marked that they share, this one. Okay, so I'm going to call that angle ACD, angle ACD, and say that it's congruent to angle ECB. And if it's overlapping and they share it, it's because it's congruent to itself. Reflexive property of congruence is what that is. Okay. Guys, I think that's it. We've got our side congruent. We've got our two angles congruent. I think we have an extra line in this proof. Ow, ow, ow. Okay, so we know that triangle ACD is congruent to triangle ECB by, what do we say, angle, side, angle. And we're done. Cool. Next. All right, we're going to do the trick again of unoverlapping our triangles. So we've got triangle ABC, easy as 1, 2, 3. So that's A, B, C. And then the other one is DBC. D, B. Whoa. Okay, would you fix this for me if I had forgot to fix it on your paper? It should say, hold on, let me fix it. It should say DCB, right? Okay, we'll fix it. It's fine. DCB is what it should say. Okay. DCB. DCB. Yes. DCB. Okay. So, well, what are they giving us? Well, they're telling us that AC is congruent to DB. Okay, they're also telling us that angle ABC and angle DCB are right angles. Yep. All right, the last thing that we're going to have to use is the reflexive property again to say that BC, whoops, is congruent to itself. Okay. Okay. So let's rock and roll. Segment AC is congruent to segment DB. That is given. Okay, next. Angle ABC and angle DCB are right angles. That was also given to us. Now, if we just say that these right angles are congruent, then we're in a position where we're having to use angle, side, side. Okay, and we can't use angle, side, side, so we're not just going to say these angles are congruent. What we're going to say is that these triangles are right triangles, because if we have right triangles, then we can use our hypotenuse leg. Okay, so it's tempting to say that the right angles are congruent, and that's true, but it's not helpful in this particular situation. So we're going to go the other route and say that these are right triangles. So triangle A, B, C, and triangle DBC, no, DCB are right triangles. And that comes from the definition of a right triangle. Okay, let's use the reflexive property and say that that shared leg is congruent to itself. So pay attention to the order. It's BC in one triangle, and it's CB in the other. So BC is congruent to CB by the reflexive property of congruence. Okay. Now, we've got AC congruent to DB. That's our hypotenuse. Okay. We've said that BC is congruent to CB. That's our leg. And very important, mission critical, is this right here. We've said that they're right triangles, which means that we can now use hypotenuse leg. So, triangle ABC is congruent to triangle DCB by hypotenuse leg. Ta-da! Bye.